Hello guys, welcome back to my channel. I'm here with another exciting project, weather prediction modeling. Like ever, I'm gonna import necessary libraries and load the data. Okay, I want to explain something about the dataset. So first of all, we need to guess if we have a good condition for barbecue or not. Okay, based on the feature that we have here. And for the first step, I'm gonna merge the dataset on the date column. Check if we have any missing data. And here for X, I consider every column that contains Oslo city as X, and for Y, I consider Oslo barbecue weather. And here Y is false or true. False means the weather is not good for barbecue. True means it's good. And I just convert it to 0 and 1. 0 as false and 1 as true. I want to find the correlated columns to target. And you can see here, if we have any column that is close to 0, it means less correlated to target. And as we go up and be closer to 1, it means the column is more correlated to target. And another step is feature selection. Feature selection, we want to see if we have any, actually we want to find the related features. And I use several different ways. One of them is correlation, and another one is K-based, and also RFE and lasso, and also I just find a common feature between them. I consider these columns as my features based on what I have done in previous actually cell. This is my new X, and Y, I didn't change anything about Y. Okay, here I train different models and see which one is better and compare them in order to find the best model to predict good condition for barbecue. Here I just ignore the warning and split the data, standard scalar, and different models is like logistic regression, support vector machine, random forest, k-nearest, and also artificial neural network. And there is a point that I want to talk about, why we are using artificial neural network. So the reason is artificial neural network is easier to use in compare with neural network. Okay, and we just can make everything easier, and by using artificial neural network. Okay, let's see different score for different algorithm. Okay, these are the accuracy. Logistic Regression 0.96, SVM 0.95, and Random Forest 1, and Decision Tree 1, and ANN 0.96. I just want to actually compare the results. So the first one is accuracy scores. As you see, the random forest and decision tree got 1 and the best score that we want. Correlation heat map. And here you can see the blue one starts from minus 0.4 and to 0.6. As we go up, we closer to 1 or minus 1, doesn't matter. It's minus or it's positive or negative, it doesn't matter. It means it's really correlated to the target feature. And as we be close to 0, it means my feature is not actually correlated to target feature. And here is another way that we can visualize the data. And about the confusion matrix, let me show you what will happen. Confusion matrix, I'm going to describe it for logistic regression, but it's same thing for all the algorithm. So here is true label is 0 and the predictor label is 0. It means it is 0 and we really predict it's 0. 6 or 1 times we can predict it as a true label for 0. And 12 times we actually the true label was 0 but we predicted as 1. And for here the true label was 1 and we predicted as 0. Okay, it means 12 and 13 they are not the correct answers. Actually we predicted wrong. And here we true label was 1 and we predicted as 1. Okay, for confusion matrix maybe I will make another video because there are many things about the confusion matrix that you need to know, but I just want to keep this video short. Thank you so much guys and see you in next video. Thanks.